Okay. One part of the fundamental theorem of calculus part 2 that we talked about last time, I didn't really stress last time, is that there's an if part. If f is continuous on a to b, closed interval, then the integral from a to b, f of x dx, equals the antiderivative evaluated at b minus the antiderivative evaluated at a. Our nice little formula that links integrals, well, basically it links integrals to derivatives. I mean, it's antiderivative, but antiderivatives are highly related to derivatives. But anyway, yeah, this part we didn't really talk about in last time about f being continuous. Should note here, big F is an antiderivative of f. On the homework problems, which may have started there, that didn't come up because we were talking about continuous functions. Well, most of them are continuous everywhere, but we didn't run into a problem where that didn't come up. This one, however, let's talk about it. From -2 to 3 of 1 over x squared dx. That being f of x, 1 over x squared, or x to the -2 power. The antiderivative of that, what's the antiderivative of x to the -2? Antiderivative of x to the -2, big F of x, would be what? -1 times x to the -1 plus c, but one specific one. Okay, but what I was going to point out, yeah, that's the antiderivative, but this does not equal -3 to the -1 minus -2 to the -1. And it's because of that first qualification right here. What do we note about this function over these limits? It's not continuous at 0. Between -2 and 3, we've got a discontinuity, don't we? At 0, x can't be 0 here. So there's not a continuous function from -2 to 3. That's why this antiderivative stuff doesn't work, because that's a big if. If's a big word. So if the if part doesn't work, then neither does the then part, right? It doesn't follow. So you've got to have continuous. So, I mean, that'll give you a number, but it won't give you this integral here. To do this integral, actually, in this book, it comes up in Calc 2, so we have to go about it a different way to find that integral. But you can't do it directly as we have been. Okay, so that is yeah, can't do this because it's discontinuous at 0. Which is in our limits. Now, that being said, what if I wanted to go 1 to 3, 1 over x squared dx? Would that be equal to then, knowing that the antiderivative is that, -3 to the -1 minus, -1 to the -1? Could I do that? Would that be right? Well, the antiderivative has a negative in it too. Yeah. Yeah, I think I actually forgot a negative here. But anyway, yeah, this one we can do this way because it is continuous from 1 to 3. 1 over x squared is, isn't it? Yeah, the breaks at, let's see, 1 over x squared. Yeah, 1 over x squared looks like this. The break's at 0, so I can't go across 0, but if I don't cross 0, I'm okay. So I could do it either on the positive side or the negative. If I'm exclusively on the positive side or exclusively on the negative side, I can still do this integral. So this would be true. So as long as you don't capture that discontinuity, you're okay to do the antiderivative part 2 fundamental theorem of calculus. Okay. It is continuous here, so you can do it that way. So you get what? Negative 1/3 plus 1, just 2/3. Okay. All right. So that's number 1 problem of the day. Is that okay? Any question or concern? All right. Let's do another one here. For now, yeah. You just say, can't evaluate it using the antiderivative. Yes. That's how you explain it. All right. Well, that one, you would know that one's discontinuous because of the denominator thing, right? You can't have x being 0 there. So, I mean, you're using, yeah, you can look at the graph, you can look at the function itself and tell. But yeah. All right. Yeah, for this integral, number 1, mention what? First of all, evaluate the integral. All right, so that's just the the basic rundown there. Oh, I guess mention again. The variable doesn't matter. We're doing this. This tells you that we're doing the integral with respect to t. So these are t. So this is just straightforward power rule, right? What do we got? 1/4 t to the 4th minus 3/2 t squared plus 1t or t from -1 to 2. So we get 1/4, plug in the 2, that'd be 2 to the 4th, which is 16, minus 3/2 times 2 squared would be 4, plus 2, and then do the minus. With the 1s, -1. -1 to the 4th is +1. -1 squared is +1. And plus -1. There. So what do we got? That would be 4 minus 6 plus 2. That would be minus 1/4 plus 3/2 plus 1. Whatever that is our value. Somebody got it? What does that come out to be? Well, those cancel out. So it'd be 2.5 minus 1/4. So that 2 1/4? 9/4? I believe so. Somebody check me on that. Is that what you get? What you got? Nobody's helping me out? Yeah. Okay, thank you. All right. Leave me hanging here. All right, number 2. Number 2 is interpret the value in terms of the graph, or something to that effect. In other words, graph this thing and show me what that integral represents. Well, the graph, I'm graphing the y would be equal to t cubed minus 3t plus 1. That's what I want to graph. What does it look like? Well, it looks like something vaguely resembling this. Okay, goes here. And it peaks out right about here at -1. Crosses over somewhere like that. Then like that, okay? All right, so that being the graph, interpret the integral. What's the integral tell me? The net area between the curve and the x-axis. So between what and what? Between -1 and 2, right? So between -1, right here, and +2, which it looks like that just passed, yeah, just right there. So I'm going from -1 to 2 there. That 9/4 is this net area, isn't it? It's the net area here minus here, here, plus here. So yeah, it's the net area. So 9/4, this area we found, 2 1/4, is the net area between the curve and the x-axis. Between -1 and 2. All right. Same thing as we've been doing. Now we're finding it exactly. We've been doing it with rectangles. Now we can do it with infinitely many rectangles in a roundabout sort of way, right? Using the antiderivative. So again, just emphasizing that fact. Is that okay? All right. Well, I think we talked about that one. Yeah, all right, so let me do a couple more here. Is that okay? Questions or concern? Net area. Yeah, that integral is still going to take into account below the x-axis is negative, above the x-axis is positive, because it's, like I said, it's coming from the rectangles, and that's what the rectangles were. Below the x-axis ones were negative. Okay. What about this integral? Tell me what to do here. 4 to 9 of square root of y minus 3y squared dy. How would I evaluate that thing? We sort of did one earlier, but what do you think? Make this one y to a power, right? What is the square root of y in a power form? Y to the 1/2. Same thing here, right? Change that to be, well, basically move the y squared to the top. And on top it would be 3y to the -2. So yeah, you just want to change everything to the top or to powers if you can. Because then it's just antiderivative power rule for the ones we're doing so far. Yeah, just add 1 to the power here. 1/2 plus 1 is 3/2. Divide by 3/2, which means, remember, that would be the reciprocal. Be 2/3. Right? Here, well, we got -3. Well, -2 plus 1 gives me a -1, so it'll be y to the -1, but I've got to divide by that -1. Run that 4 to 9, so I get, what, 2/3. It'd be 9 to the 3/2. Minus minus makes a plus. 3 times 9 to the -1. Minus, then plug in the 4. 2/3 times 4 to the 3/2 be plus 3 times 4 to the -1. I'll have to go ahead and do these by hand just to practice a little bit. All right, so it'll be 2/3. Again, the two denominators is square root. So you got the square root of 9, and then you cube that, which is 27. 9 to the -1, flip it over, so that's going to be 3 times 1/9. Over here we'll have 2/3 times the square root of 4 cubed. That's what that would mean, right? It'll be 2 cubed, which is 8. And then this will be 3 times The negative 1 flips it over. Cancel out. So we got 18 plus, that'd be 1/3. Minus, that would be 16/3. That'd be 3/4. Anyway, good practice. 18 plus 1/3 minus 16/3. And then it'd also be minus 3/4, wouldn't it? Got it? 12.25? 12 1/4? Or 49/4? However you want it there. Okay. Is this okay? Problems or concerns? Look okay? All right. Okay, second one here, integral from -2 to 4, x times x squared minus 7x minus 2 dx. X cubed, I'm sorry. Did I say x squared? I meant x cubed. All right. Yeah, so again, we mentioned this just a second ago, but yeah, you don't have, if you got a product, you do want to go ahead and multiply that product out if you can. Best way to do it. So go ahead and distribute the x in. Not that hard to do here, so make it the integral -2 to 4 of x to the 4th minus 7x squared minus 2x dx. So that would be 1/5 x to the 5th minus 7/3 x cubed minus 2 over 2. So it would be 1x squared from -2 to 4. So that would be 1/5 times 4 to the 5th minus 7/3 times 4 cubed minus 4 squared. And then minus with the -2. -2 to the 5th would be -32. Minus 7/3 times -2 to the 3rd would be -8. And then minus 2 squared is positive 4, so it'd be minus 4 in the end there. If I did all that right. So altogether, what do we got? 4 to the 5th is 1024. 1024 over 5. Minus 4 cubed is 64. 64, so we got 448 over 3. Minus 16 minus, that'd be -32/5. Plus 56/3 minus 4. Do all that out, and we should have it. Okay. Usually get some nice fractions here. I get 31.2. Anybody else get that? Which is, 31 1/5. Something like that. Okay?